This is Sanjay Gangal from EDACafe. I'm here with Hitendra, Divecha, and Brendan Bautz from Cadence Design Systems. Hello, Hitendra.
Hey, how you doing, Sanjay?
Well, thank you so much for joining us. Understand you manage Tempus Momentum. Tell us about it.
Sure. So this is a great question, and we certainly have seen Tempus momentum right with our customers and right in the market space. Especially over the past couple of years. We have seen tremendous so to speak growth for Tempus. Now that's whether for ECO usage or for sign off. In fact, we have about 70% of top 20 semiconductor companies who are using Tempus today in production, either for sign off or for ECO purposes. When it comes to Innovus implementation, Cadence platform specifically, we have I would say 70 to 75% of those customers use Tempus ECO in production today. When it comes to advanced nodes, tape outs, for example, and specifically FinFETs, we have I would say close to 200, 250 plus tape outs that we have customers have done using Tempus today, right? So certainly there is that momentum from our customers who are trusting, right, and signing off with confidence with Tempus today.
Okay, and what are some of the customers' main challenges when it comes to more designs?
Yeah, that's a good question, right? So, when we look at challenges, right, so we have essentially kind of a 3 point of views, right? There is the design, point of view, right? And then there is the modeling, challenges. And then finally, the customer, point of view, right? Let's divide this into two phases, so to speak, right? So, at 40 nanometers and above, things were pretty manageable, right? If you look at from a design standpoint, from the complexity, right? And yes, there were competitive pressures and, design closure challenges from a customer standpoint, but, those were, manageable. For advanced node designs, this is where we see, the complexity increasing, okay? So, if you look at from a design standpoint, right, I mean, now we are looking at, 200, 300 million plus instance design, right? So, these are big, AI, mobile, automotive types of designs. There is increasing number of domains, right? There is increasing number of, the sign-off views that our customers have to sign off with. Increasing numbers of, interconnects, corners, right? And multi-modes and multi, corners, so to speak, right? And so, so that's definitely, right, complexity from a design standpoint. From a modeling standpoint, obviously there is, I would say, full LVS, CCT, types of challenges, via variations, right? Voltage scaling, right? The amount of pressure there is for customers to design with ultra low VDD, for example, right? Power requirements are shrinking, right? So, that creates, additional level of complexity from a modeling standpoint. Now, when you look at from a customer standpoint, they are essentially under siege. While, their time to sign off is increasing, at the same time, the number of iterations that it takes for them to get to the design closure, that's increasing. The pressure that they have to push the PPA limits, right? In essentially, producing, better performing parts, okay, or the chips, that is increasing, their time to market is shrinking. Okay. Now, let me make it clear. This is not, just a regular time to market that everybody talks about, right? I mean, this is time to market, but with the better performing chips, okay, or parts, right? So that's the distinction, okay? So, when we, talk to our customers, this is what they tell us, right, about, the need for them to shorten the time to market while producing, the best, performing chips, okay? And so they tell us essentially they have, 5 unique, requirements, right, or the challenges that will allow them to shorten the time. Number one is clearly the number of iterations that they have to do during the design cycle, that needs to go down, right? Because, that has, direct impact, right, on the time to market. Second thing is, an ability for a tool to provide, better optimization, QoR, which we call, quality of the results, right? And, the whole idea of, PPA, which is performance, power, and area, right? And I believe, that is the holy grail, right? That allows them to produce, the better chips, right, with reduction in their time to market. Obviously, fastest design closure turnaround time, because, this allows them to, take the GDS to their foundry partner for manufacturing purposes. Then the other thing is from a tool perspective, right, an easy to use tool, so that, the designers, right, do not have that much time, right, to ramp up, right? I mean, that should be something very easily that can be plugged to their implementation, for example, right, and the sign off, so that, they don't have to, essentially go read, technical papers in order to run the tool, right? And then lastly, right, it's all about, unmatched support that you get from, the vendor, right, throughout the duration of the design cycle, right? So that, if there are any issues, there is a timely addressing of those issues, right, by R&D, by, the support team, right, which is application engineers, who are, highly educated, right, in the sense they understand not only, the customer designs, but they understand our tools as well, right? So, those are the 5, essentially challenges that, our customer face in order to shorten their time to market with producing, the best parts.
Okay, and how does Tempus address these challenges? Brendan?
Yeah. Well, so from an architectural perspective, we address the time to market and the power performance area problems principally through integration. So it's Tempus working together with our place and route tool, Innovis, sharing common code, common delay calculators and timers that ensure that customers have a highly convergent flow from their place and route activities down through their ECO sign-off activities, and ultimately at the very, very tip, the sign-off itself. And we've been working for many years to evolve and improve the optimization algorithms themselves to really drive what we believe is, and really our customers believe, the best power performance area of results in the industry. We've worked with a breadth of companies at a wide range of technology nodes, including the absolute lowest technologies available today, and consistently Tempus optimization, Tempus ECO, Tempus sign-off, along with Innovis, have delivered on customer expectations.
And have you gone down to 5 nanometer or 3 nanometer designs as well?
I'll just say yes.
Okay, and do you work with all different foundries?
Absolutely, yes. So an important aspect of this is trying to address multiple market segments, and different foundries play in different market segments. So everything from your advanced networking data center to mobile type parts on back to your mil-aero and automotive parts as well. So by working with a breadth of different foundries, we have a broad range of experience and capability when it comes to optimization. So your question about 5 nanometer and 3 nanometer. So certainly that's one important aspect of our capabilities, one that we have a lot of unique capability and a lot of experience in addressing. But this solution is also applicable and very valuable to even the 22 and 28 nanometer type process nodes, where customers really are driven to get the best timing, the best power, and as Hitendra said, really the best schedule, time to market. and that's critical in the overall solution.
Now, as you go down to 10 nanometers, 7 nanometer,
Yeah.
or lower, you start getting a lot more IR drop problems. Is Tempus able to handle that?
Oh, so that's a great question. So as the process nodes have evolved and shrunk, really what we've seen is the convergence of timing with IR. And the need there is really to concurrently solve both problems. And it really even starts back in place and route. But when you look at sign-off, you have to have that capability of analyzing, of stimulating the design, of analyzing the timing, and concurrently analyzing the IR drop to get the proper analysis. And so this is what the Tempus Power Integrity product brings to market. It marries the Voltus EMIR capabilities with the Tempus STA capabilities, all built on a common data model, actually a common binary, that ensures no need for file transfers, and having that concurrent analysis capability coupled with the Tempus ECO optimization gives designers a truly convergent method of closing IR with timing, in particular at advanced nodes.
And does Tempus work primarily with digital designs, or does it work with analog designs and mixed signal designs as well?
Mm-hmm. Okay, yeah. So Tempus, of course, is a digital timer, but through our OA interface and our integration with Virtuoso, we have capabilities of working in that analog mixed signal world. And this is particularly beneficial to designs that have multiple analog and digital hierarchies. When you mix that all up, it makes it very difficult for mixed signal designers to isolate just the digital component for the purposes of STA. And so utilizing Virtuoso and the OA interface, the Virtuoso designer themselves can gain access to Tempus for mixed signal digital STA in context. So it makes it very easy to use and very convenient to adopt.
And what are some of the other challenges that Tempus has had to address as we have moved from 28 nanometer down to the FinFET area?
Sure. Yeah, so certainly as we've moved from 28 to FinFET, design size has gotten much larger. And, and while all the same schedules have not increased, time to market pressure has gotten worse. So Tempus has a unique technology to address very, very large designs, 400 million cells and above. And this technology is called distributed STA. And it's the ability to take a design and run a single process corner across multiple machines. And this is how we can scale, whether it be on-premise or even on cloud, to handling the largest designs in the industry. It also has a side benefit of allowing customers to use those smaller machines that they may have available, even on the largest designs. So DSTA is one of the key technologies we have to solving that the design size challenge. Conversely, the number of modes and corners has increased as you go with more advanced technology. So we have a complementary technology called concurrent multi-mode, multi-corner analysis that allows Tempus to simultaneously analyze multiple modes and corners together and do so in a very efficient manner. So this is a great option for analyzing a large number of modes and corners on a single machine.
And I'm assuming when talk about distributed computing, you're talking about both multi-core as well as multiple different computers and multi-threading.
Yes,
all three?
yes, very much so. So all of our solutions start with highly multi-threaded code. And so that DSTA, the distributed capability, is almost a hyper-threading type technology where we're scaling out on multiple machines. And as we do that, of course, we're picking up multiple cores per machine. So this enables running STA on potentially hundreds of threads.
Wow, that's quite something. Anything else that I've not asked you guys want to cover?
So just to summarize, Hitendra set up many of the challenges that are facing customers today in terms of time to market and meeting your power, performance, and area goals, how to analyze very large designs, and really how to get your chip out to market as quick as possible. So with the common engines, with Innovus, with some unique capabilities that we have for sign-off, like concurrent MMMC and distributed static timing, it's really these solutions together that work to meet our customers' objectives.
Okay, and what is the best way for people to find out more about Tempus on the internet?
Oh yeah, well, of course, for initial information, please visit the Cadence website, cadence.com, where you can download data sheets on the products themselves, Tempus in particular, Tempus Power Integrity, and learn a little bit about how users have successfully deployed our software amongst the different verticals. So that's how.
Okay. Yeah, and it okay if I ask you guys a couple of personal questions?
Go ahead, shoot.
It depends. Go ahead.
Let me ask you, what do you guys do for fun? Or what is a personal passion outside work?
I really enjoy photography. And by no means am I the best Cadence photographer. There's one person in particular who's, in my view, the best Cadence photographer. But nonetheless, I enjoy landscape photography and portrait photography. It's a good blend of like art and technology together.
Okay.
Yeah. So I have a 6-year-old son, Jay. So right now, I'm pretty much occupied, right, in babysitting her, right? But no, I mean, I enjoy sports, whether it's live or watching. So soccer, I grew up in East Africa, in Tanzania. So soccer was a big thing, right? And so obviously followed that, and then when I came to US, obviously introduced to American football, basketball, baseball. I'm not so kosher with that yet, but hockey, for example. So it's a lot of sporting activities, but my 6-year-old really keeps me busy with her stuff. So yeah, but no, actually, and I've also started coaching soccer for under 6-year-old now. So I teach. So my daughter, plays soccer. So yeah, I've been teaching for 2 years. Obviously, this year we couldn't do it. So yeah, that's I would say that's probably one of the things that I enjoy the most.
Yeah, I used to be a soccer coach a long time ago. My son is 27 years old, but when he was 6 years old, I used to be a coach, and it was a real challenge with these little kids to keep their focus on the football.
Oh, yeah. It's not just the kids, it's the parents also, right? So,
yes.
It's a dual duty you got to do, but no, but I enjoy it. I think it's fun.
And Brendan, you said you like portrait photography. Is it objects, people?
Yeah, well, oftentimes people. So kind of talking about kids, my kids are in middle school and high school now, so I've had a few years with them, but documenting them over the years and doing some community work with photography is nice way to capture the moment, both candid as well as more formal still photos.
Tell us something about yourself that most people at Cadence don't know about you.
Yeah, well, two things. I think I already talked about it, right? One being that I was born and raised in East Africa, right? People typically don't associate that, right, when they see me. Coaching, obviously, right? Because it's hard for them to imagine me being a coach. So not without those two, I would say I always wanted to be a pilot. Actually, growing up, that was my passion. And obviously, made a turn right into engineering, right, and into marketing as a profession. But I do take pilot classes. right on the side. So I've not been active recently, but that's still my goal one day, right? To take plane, and fly it myself. So. But yeah, that's one thing I think a lot of people don't know about me.
I did not know that. Yes, I did not.
Yeah, and
Actually, I guess one thing
Go ahead,
I have soloed before.
Oh, okay.
Okay.
We can talk about that another time. Yes.
Good.
Yes.
Yeah. So right now, my thing is just the simulation, right? So there's a place here in the Bay Area that I go. There's one place in NASA, NASA Research Park. There was a company that does simulators. So, I have a friend of mine, who has put me in touch with those guys. So that is where I do. But, hopefully one of these days, I'll go to Palo Alto and, fly a small plane from there.
Okay. So are you going? So I'm assuming you're not going past simulator and not even with a.
No.
Okay.
Yeah, and after my daughter was born, then my wife said, I think priorities first. So obviously, that's extra level of responsibility, I would say, right? So, but no, I do simulator now and then, yes.
And can I also ask you, what age did you come to USA from Tanzania?
I was 19 years old when I came to US.
Okay.
Yeah.
Okay.
Came to school, went to Boston. So after I finished my primary, secondary education, O levels, A levels, right? If you remember the British educational system, right? So I came here and then went to Boston for university, and then moved to Bay Area, and I've been here ever since.
That's pretty awesome. Well, thank you guys. Thank you both of you for taking time to record this interview and sharing some of your personal history as well. Have a great day and stay safe.
Great. Yeah, you
too,
too.
Sanjay.
Thanks, Sanjay.
Thank you.
All right.
This is Sanjay Gangal from EDACafe.